Good day, ABM learners. Today, we're going to tackle the data presentation and analysis and its crucial role in the business world. Data analysis is like a superpower that allows businesses to make informed decisions, understand customer behavior, and predict market trends. It is an essential tool for success in today's fast-paced and data-driven business environment. The most essential learning competencies in this video lesson are the following. 1. Compare the forms, textual, tabular, and graphical, of business data. 2. Analyze and interprets the data presented in the table using measures of central tendency and variability and tests of significant differences. How do businesses present and analyze these data in different ways? There are three main forms of data presentation: textual, tabular, and graphical. Each form serves a unique purpose and is used in various real-world business scenarios. Textual data is presented in written or descriptive form. In this form of presentation, data is simply mentioned as mere text, often in a paragraph. It's commonly used when the data is not very large and is useful when we want to supplement qualitative statements with some data. However, it's important to note that this form of representation is subjective and may require additional explanation to convey its meaning effectively. For example, it could be a written report summarizing sales figures, customer feedback, or market research findings. Textual data provides detailed information and is often used for in-depth analysis and decision-making. Example: male customers correspond to 67 and 53% of the total customers of an internet shop. With a frequency of 79, male customers ranked first. Female customers ranked second with a frequency of 38 or 32 and 48%. Textual data allows for detailed information and is often used for in-depth analysis and decision-making. However, it may require additional explanation to convey its meaning effectively. Next is tabular presentation. Tabular data is organized into rows and columns or in the form of tables, often seen in spreadsheets or databases. Tabular data is perfect for presenting vast amounts of data, making it easy for the reader to interpret the information. It's self-explanatory, with segments that depict what the data wants to convey. This form is commonly used for organizing and summarizing data, making it easier to compare and analyze at a glance. The raw data is neatly arranged for easy reference and comparison. Businesses use tabular data to track sales, expenses, inventory, and other operational metrics. Tables are commonly used in organizing and summarizing data. Tables should be simple, easy to read and understand, and should contain only relevant data. A table essentially consists of the following parts. Table number: the number given for each table, usually at the middle or toward the left of a table. It helps readers to identify one table from another. Title: the title is the main heading, usually placed just below the table number or beside it. It should be short, clear, and descriptive of the nature of data presented in the table. Caption: the caption refers to the heading of each column, also referred to as the box head. Stub: stub refers to the heading of each row. Body: body contains the data, which is the most important part of the table. Head note: head note, also known as prefatory note, it indicates the units of measurement of the data. Footnote: footnote clarifies the point which may not be clear in the table. Source note. Source note indicates where you found the data presented in the table. Tabular data is great for organizing and summarizing data, making it easier to compare and analyze. However, it may not be as visually engaging as graphical data. Lastly, graphical data. Graphical data is presented visually through charts, graphs, and diagrams. Visual representations make complex data easier to understand and can reveal patterns, trends, and relationships that might be less apparent in textual or tabular formats. Graphical data is commonly used in presentations, reports, and marketing materials to communicate key insights at a glance. Graphical data, while visually engaging and able to reveal patterns and trends, may not provide the same level of detailed information as textual or tabular data. Each form of data presentation plays a vital role in helping businesses understand and communicate information effectively. Whether it's analyzing sales performance, forecasting market demand, or identifying areas for improvement, data analysis in its various forms is a game changer for businesses. Measures of central tendency, variability, and test of significance. Measures of central tendency. Measure of central tendency is the summary of measure that attempts to describe a whole set of data with a single value that represents the middle or center of distribution. There are three fundamental statistics that measure the central tendency of data, and these are the following: mode, median, and mean. Mode. The mode is the most frequently occurring value in a data set. Mean. The mean is the arithmetic average of all the values in the data set. X bar or mu, the mean or average is calculated by adding together all the values and divided by the number of observations. And the formula for mean is equal to sum of all the observations divided by the total number of observations. Median. Median is the middle value or midpoint in a distribution when the values are arranged in ascending or descending order. If the number of observations is odd, the median is the middle value. If the number of observations is even, we find first the two middle value and add the two middle value and divide. Example 1. Find the mean, median, and mode of each of the following set of data. A group of students obtained the following scores in a business math quiz: 13, 12, 14, 15, 13, 11, 10, 9, 8. Arrange first these scores in increasing order: 8, 9, 10, 11, 12, 13, 13, 14, 15. To find the mean, average, we add up all the numbers and then divide by the total count of numbers. Mean is equal to the sum 13 plus 12 plus 14 plus 15 plus 13 plus 11 plus 10 plus 9 plus 8. Divided by 9. That will bring us 105 divided by 9. And the mean will be 11 and 67. To find the median, we arrange the numbers in ascending order and then find the middle value. If there are two middle values, we take their average. Arranging the scores in ascending order: 8, 9, 10, 11, 12, 13, 13, 14, 15. As there are 9 numbers, the median is the middle number, which is 12. The mode is the number that appears most frequently in the data set. In this case, the number 13 appears the most, occurring twice. Example 2, where our data set is even. Find the mean, median, and mode of each of the following set of data. The score of 8 students in mathematics quiz are the following: 4, 4, 5, 6, 7, 7, 8, 9. To find the mean, average, we add up all the numbers and then divide by the total count of numbers. Mean equals sum of 4 plus 4 plus 5 plus 6 plus 7 plus 7 plus 8 plus 9 and divided by 8. Equals 50 divided by 8. Equals 6.25. So the mean is 6 and 25. To find the median, we arrange the numbers in ascending order and then find the middle value. If there are two middle values, we take their average. Arranging the scores in ascending order: 4, 4, 5, 6, 7, 7, 8, 9. As there are 8 numbers, the median is the average of the two middle numbers, which are 6 and 7. Median is equal to the sum of 6 and 7 divided by 2. And that is 6.5. The mode is the number that appears most frequently in the data set. In this case, both 4 and 7 occur twice, making them bimodal. We will now proceed to variability. Variability measures how much your score differ from each other. Along with measures of central tendency, measures of variability give us descriptive statistics that summarize our data. The 4 frequently used measures of variability are the following: the range, interquartile range, variance, and standard deviation. Range. The range is the difference between the highest and lowest values in a data set, providing a simple measure of the spread of the data. R equals H minus L, where R equals range, H equals highest value, L equals lowest value. Example: compute the range for the given set of numbers 12, 13, 14, 17, 18, 20, 22, 24. To compute the range for the given set of numbers, we use the formula range equals highest or maximum value minus lowest or minimum value. Given set of numbers, the highest or maximum value is 24. Lowest or minimum value is 12. Range equals 24 minus 12. So the range is 12. Next is interquartile range. Interquartile range, IQR, is a measure of variability based on dividing a data set into quartiles. Quartiles divide a rank-ordered data set into 4 equal parts. The values that divide each part are called the Q1, Q2, and Q3. Quartile 1 is the middle value in the first half of the rank-ordered data set. Quartile 2 is the median value in the set. Quartile 3 is the middle value in the second half of the rank-ordered data set. The formula to find the interquartile range is IQR equals quartile 3 minus quartile 1. Example for odd number data. Let us assume the following data on the final exam of a business math subject: 53, 72, 54, 80, 84, 83, 91, 98, 100. First, order the data. 53, 54, 72, 80, 83, 84, 91, 98, 100. Next, find the median or middle value. In this data set, 83 is the median. Then, separate the data into two halves. Lower half, 53, 54, 72, 80. Upper half, 91, 98, 99, 100. Find the median of each half. Lower quartile or quartile 1 equals median of lower half equals 54 plus 72 divided by 2 is equal to 63. For the upper quartile or quartile 3 equals median of upper half, so that is the sum of 98 and 99 divided by 2. And the answer is 98.5. Finally, calculate the interquartile range, IQR. IQR equals quartile 3 minus quartile 1. IQR equals 98.5 minus 63. IQR equals 35.5. So, the interquartile range for the given data set is 35.5. To find the interquartile range, IQR, for an even data set, you follow similar steps to the odd data set, but with a slight modification due to the even number of data points. Here's how you can find the IQR for the given data set of 1, 2, 4, 6, 7, 8, 9, and 10. Since our data is already arranged from lowest to highest number, we will proceed to find the median. Since there are 8 data points, the median is the average of the 4th and 5th values. Now, divide the data set into 2 halves based on the median. Q1 is the middle value in the first half of the data, 1, 2, 4, 6. The two middle figures are 2 and 4 and the average would be quartile 1 equals sum of 2 and 4 divided by 2, so that will be 6 over 2. Therefore, the value of quartile 1 will be 3. For quartile 3, we get the second half or the upper half of the set data, 7, 8, 9, and 10, the two middle figures are 8 and 9. Quartile 3 equals sum of 8 and 9 divided by 2, will be 17 over 2. So quartile 3 value is 8.5. Finally, calculate the interquartile range. IQR equals quartile 3 minus quartile 1. IQR equals 8.5 minus 3 equals 5.5. So, the interquartile range for the given data set is 5.5. Now let us proceed to variance. The variance is a measure of how close the scores in the data set are to the middle of the distribution. The variance is defined as the average of the squared differences from the mean. The variance of population mean is denoted by sigma squared. The formula for population variance is sigma squared is equal to the summation of x minus mu squared all over n, where sigma squared is the population variance. X is the element from the population. Mu is the population mean, and n is the number of element in the population. Example. Let's say we have a data set representing the scores of students in a class. 85, 90, 88, 92, and 95. First, we need to calculate the mean or average of the data set. So, mean equals the summation of 85, 90, 88, 92, and 95. All over 5. That will be 450 over 5. So the mean from this data set is 90. Now, we calculate the squared differences from the mean for each score. From the data set, the mean is 90. From the first datum, 80 minus 90 squared is equal to negative 5 squared, and negative 5 squared is 25. Second datum, 90 minus mean 90 squared is equal to 0 squared or 0. Same process to the next data set. Once done, we find the average of these squared differences, like what is required from this formula. Variance equals the summation of the quantity of x minus mean squared, all over the number of population elements. That will bring us to the variance equals the summation of 25, 0, 4, 4, and 25, over 5. That will be 58 over 5, or 11.6. So, the variance of the data set is 11 and 6.